Hi guys, welcome to my channel. In our previous video we did analyze this simply supported beam with a trapezoidal load. This what we did on our previous video. We did calculate the reactions, the shear force, and then the bending moment on part 1. So if you want to, you can check this video. I will put a link on the description. You can check it. I will put a link on the description. You can go back there and see what we did with part 1. Now we need to draw. We need to draw that bending, the shear force and we need to draw the shear force and the bending moment based on these calculations. Here is our already drawn the sketch. So we will plot our shear force and bending moment on this sketch. Let's start with the shear force. Here are the shear force calculations at each point of the beam. In this case, here as you see, I said at the x, for each value of x less than 3, the shear force is equal to 29.26. This means, let's change, we'll draw it with red color. So for the shear force, this is not to scale, so just bear with me. Obviously, if you it won't be to scale, but it's just an illustration on how we can do it. So I'll just put here 29. So this is 29 to 626, 29.26, and from here we say for x less than 3, the shear force value is 29.26. Now for a shear force between for a point between, for x superior or equal to 3 and less than 7, here is the equation. Here's our equation. So there's an unknown x in this equation, so we just replace the x with some value from 3 to 7 to get the shear force at each point. For x is equal to 3, we got this value with 29.26. For x equal to 4 is 16.76. Something like that. Yeah, it's not that so straight, but it is something like that on this interval. And then from there now, for x between 7 and 9, for s, so it's going down to straight line. So from here, so we got minus 50 and 7.4, which is also equal to 14 minus 7.4. I'm hoping I'm taking the right. Okay, that's correct. and between 9 and 11 we got 15. So between 9 and 11 is now positive, so it's from here. Okay. So this is basically the yes, this is our shear force diagram. This is our shear force diagram. Now we must draw now the bending moment based on our previous calculation, which is here. Bending moment at x less than 3, it will be 29 times 3. So at x, this will be or equal to 3. Yes, this is how it should be. And x, so we will get you will have 29 times x. This is positive, so which means at x is equal to 3, we will have 29 times 3. Okay. And on this interval now, is vary now with x, and then varies now with x, and this is our equation. This is our equation that varies with x, and we already got the value down here. So at x equal to x equal to 3 is our value, and x equal to 4 is our value. S equal to 3 and s equal to 3, we got x equal to 4. From s equal to 11, s equal to 11, the minimum is equal to 0. So from here, bending moment go back to 0. Here we go. So this is a bending moment already been drawn. So this is plus, minus, sorry. Minus, plus. So this is our bending moment being drawn. Now we need to calculate the maximum bending moment, and to do so we must calculate the point where the shear force is equal to 0, which is here. So we need to calculate this point. In this one it will be easier because we already got an equation in this interval of the shear force. So we just need to solve that equation. This is the equation we have on in that interval based on x value. So we must develop this equation and solve it to get the point at which the shear force is equal to 0. Let's retap this equation and then solve it. This x will help us get the point where the shear force is equal to 0, and by calculating the moment at that point, the moment at that point will be the maximum moment. So now let's develop this equation. This will become this value is minus, there is no negative distance, so we don't ignore this. So this is the distance at which the bending the shear force is equal to 0, and then the maximum bending moment will occur at this point. This is our x value, so we will now replace this value into this equation to get our maximum bending moment, and this will give us 29. This equation, bending moment. So bending moment now this is the maximum moment at x. So here is our diagram, and we can put in the value. This is 29.99. This is 0. Here we got 87. Here we got we're done at this level. Thank you for watching. On our next part, we are going to calculate the point of contraflexion.